All right, hey guys. This is Harmon. I hope everyone's having a fantastic quarantine day. Um, y'all's problem to complete today probably shouldn't take more than about 10 minutes. So I'm going to give you about a 5 minute video here, kind of explaining what I'm looking for. That way you have a better chance of kind of understanding. Your problem asks, which of the following does not belong? Justify a reason why each one could not belong with the other three. This is really just stating like the differences, what's different about them. Okay, and there's a lot of things in common, there's a lot of things different. Let me give you an example. So over here, I'm going to do the same exercise with these four graphs. Okay, I'm going to call them 1, 2, 3, and 4. All right, so the top left one, number 1. Now, there are more things than what I'm saying that could be true, but I'm going through and trying to state what is different about them than the other ones. And this one's not as clear as y'all's, but I think it's going to work out well. All right. So first off, you look at the first one. The thing that I notice, it's actually a couple of things. The first one is the only linear one that has a positive slope. It's the only one increasing going up. All right. The only other thing I'm seeing, and this one may actually be better, is the fact that it is the only one that doesn't have a dotted line. So it is the only one that um, has solutions on the line. Okay. So again, I'm just going through it. I'm stating what's different. This one's increasing, and it also is an equal line. All right. Number 2, the top right one. This one's probably the easiest one. Dude, it's not a line. Okay, it is a parabola instead of a line. All right, bottom left one. Now this one again is a little easy to see, but it kind of depends. This one's shaded on top. This one's shaded on top. This one's shaded on top. This one's shaded on bottom. So it's shaded on bottom or a less than sign in the inequality. Okay. All right, last but not least, now this one actually took me a little while, and I'm not exactly sure what it is they're looking for on it, but because, all right, guys, it's greater than, but these other two are greater than. It's decreasing, but this one's also decreasing. I mean, it has a negative y-intercept, but this one has a negative y-intercept. I'm going to go with the fact it has a steeper slope. Okay, that's the only thing I can think of that out of the lines that's a little different about it. You maybe noticed something. But it has a steeper slope than 1. Okay. Um, there may be something else to it, but that's the best I see for that one. So, guys, I went through and told why each of them is different than the other ones. You're going to do the same thing here. Now, I am going to give you a little bit of terminology to potentially help you out. So, a couple words that may help and their definition. So, increasing and decreasing. All right. I feel like you probably know that. Um, a couple ones you may not know are positive and negative. Okay. Now, what positive means is that it has things that are above. So, like this one's positive right here. It means it's above the x axis. Okay. Right, so, positive is where it's above the x axis, negative is where it's below x axis. Okay. That may help you out on one of these. Okay. Um, I also may use the word constant rate of change or linear. That may be helpful in this. And the other one that you may or may not notice is you probably have not heard this word before, but is continuous. Okay. All right. Now, continuous or not continuous. All continuous means is that it's connected. It's a line or a squiggle. It keeps going. Okay. For instance, this is continuous. This is not. Okay. That's all that means. I hope this helps you out on your project for today. I'll be posting one of these videos every day just to kind of give you all a little bit of a hint